Okay, so the first part of this question says, give an example of three distinct vectors in R3 that are linearly dependent and span a line. And then I have to draw the span. So for three vectors to be linearly dependent and span a line, they can just be a multiple of one vector. So right here I have three vectors, u, v, and w, that are basically just a multiple of u. So, and I had it so x1 is 0 just so I can draw the line in the x2, x3 plane. It'll be easier to see. So if we plot these, x or u will be right here. Let's see. V will be 2, 2. And w will be 3, 3 right there. So you can see that those will span a line going through the x2, x3 plane. Okay, and then the next part of this question says, give an example of three distinct vectors in R3 that are linearly dependent and span a plane. So for that to happen, all three vectors need to be within the same plane. So right here I have three more vectors. I have u, v, and w, and v is a linear combination of u and w, which is actually a property of having linearly dependent vectors. So if you draw these, u is going to be 0 to 0, it'll be right here. V will be 0 to 2, so right there. And then w will be 0, 0, 2, so it'll be right here. And so all these vectors lie in the same plane. They lie in the x2, x3 plane. They're flat on that surface, so the span would be this entire x2, x3 plane. Okay, now the next question tells me to use a rectangular coordinate system to plot u and its image under the following transformations. So u is the vector 5, 2, so you can just plot that straight up. So 1, 2, 3, 4, 5, up 2 will be about right here. And then to plot its transformations, first you have to know if it's going to be in the same space. So for each of these matrices, they're both 2 by 2 matrices. So it'll be going from R2 to R2, so it will be in the same space. So for the first transformation is right here. So all you have to do is you have to replace u with this vector right here, and this will give us 5 times 0.5 is 0.2, or 2.5, plus 0, so it'll give us 2.5. And then this next one, 5 times 0 is 0, plus 2 times 0.5, which is 1. So that's this transformation, and if we plot this, it'll be 2.5 up 1. Notice it's on the same line. So that transformation is just a scalar multiple of by 0.5. The next transformation is right here. And so if you plug in u to this, you'll get 5 times 0 plus 2 times 1, which is 2. And then 5 times 1 plus 2 times 0, which is 5. And if you plot this one, it'll be 2 up 5. 1, 2, 3, 4, 5. Now this vector is just the opposite of this one. It just switches x1 and x2 from u. So instead of being 2 over 5, u was 5 over 2. So they're just opposites like that.